In this video, we'll be learning about when a function is increasing, decreasing, or constant. We'll be determining these things by looking at the graph of a function. When you learn about derivatives in calculus, you'll be able to determine these things based off of the formula for the function. But for now, we'll stick to looking at graphs. We say that a function is increasing on an interval of x values if the graph goes up as we trace the graph from left to right on that interval. Similarly, we say that a function is decreasing on an interval of x values if the graph goes down as we trace from left to right on that interval. And then lastly, we say that a function is constant on an interval of x values if its corresponding outputs or y values remain the same throughout that interval. Let's now take a look at some examples to get a sense of what these definitions mean. In example A, we're given a graph of a function and we want to determine where it's increasing, decreasing, and constant. So all we have to do is trace this graph from left to right, and as we trace, we want to decide whether the function is going up, down, or remaining flat. Starting at our leftmost point, -4, 2, as we trace to the right, our graph goes down all the way until we get to the point -1, -2. Since our graph went down starting at the x value -4, going all the way until the x value -1, we say that our function is decreasing on the interval -4 to -1. Now let's pick up where we left off at -1, -2. If we keep tracing our graph to the right, we see that our graph remains flat until we get to the point 2, -2. So for all of the x values between -1 all the way until 2, our corresponding y values remain the same. And so we say that our function is constant on the interval -1 to 2. Now let's return to our graph and pick up where we left off at 2, -2. If we keep tracing our graph to the right, we see that it goes up now until we get to the point 5, 1. So for the x values from 2 all the way to 5, our graph is increasing. So we say that our function is increasing on the interval 2 to 5. So all we had to do was trace our graph from left to right, see where it's going up for increasing, see where it's going down for decreasing, and see where it remains flat for constant. Now let's look at example B. Again, we're going to trace our graph from left to right. So starting at the leftmost point, -5, -1, if we trace to the right, we see that our graph goes up all the way until we reach -3, 3. So for the x values from -5 all the way to -3, our graph is going up, which means that our function is increasing on the interval -5 to -3. Now, if we continue tracing our graph starting at -3, 3, as we move to the right, our graph goes down all the way until we reach the point 0, -2. So for the x values from -3 all the way until 0, our function is going down, which means our function is decreasing on the interval -3 to 0. Now let's pick back up at 0, -2. If we keep tracing our graph to the right, we see that it remains flat all the way until we get to the point 2, -2. So for the x values from 0 all the way to 2, our outputs or our y values remain the same, which means that our function is constant on the interval 0 to 2. Now if we continue tracing our graph starting at 2, -2, if we keep going to the right, we see that our graph goes down until we reach the point 4, -3, which means that for the x values from 2 all the way to 4, our graph is going down, which means our function is decreasing on the interval from 2 to 4. So in this video, we learned how to determine where a function is increasing, decreasing, and constant by looking at its graph.